Hi, my name is Dana Golden. Today we're going to finish up our look into non-market valuation and giving you some tools to perform that cost-benefit analysis with a look at stated preference methods. Stated preference methods are survey-based approaches to estimate the value of number of goods by directly asking people about their preferences. So instead of revealed preference methods where we use the market to figure out how much things are worth, or benefit value transfers where we say this is how much this model says it's worth, this is how much this other good is worth, here's how we think that compares. What we're saying in stated preference methods is how much do you think it's worth, and we directly ask that. And so it directly measures individuals' willingness to pay or willingness to accept compensation for changing non-market goods. So the classic way this works is through what we'll see in a moment called contingent valuation, where you present a hypothetical scenario and get preferences. It captures both use values and non-use values. It's a bit questionable how well it captures non-use values, because you are not particularly sure how much people are thinking about this, but if you're doing it right, you can capture the entire value to humanity. So the most obvious one from this, and this is the one most people think of when they think about stated preference methods, is contingent valuation. It's a survey-based economic technique to estimate the value individuals place on non-market goods. So you give the person a hypothetical scenario, you say, how much would you be willing to pay to stop the destruction of the Everglades, or how much would you willing to be paid to accept slightly more contaminated water? And this allows you to value environmental goods like clean air and biodiversity. Biodiversity would be really hard to value with a revealed preference method. There's even less of a market for biodiversity than there is for something like clean air, which you can back out using hedonic pricing. So like this really is a great method for valuing things that, how does anyone know how you value biodiversity? And you can get a lot of things out of contingent valuation that you can't get out of revealed preference. So an example is valuing clean water access. A community is asked their willingness to pay for a project that ensures clean water access to all households. The project will cost $10 million to improve water quality in the local river. Would you be willing to pay X dollars per year for an additional tax to fund the clean water project? Yes, this is a survey. You provide a random sample of this survey. Maybe you mail everyone the question, see who responds. Given different values of X, would you be willing to pay $10? Would you be willing to pay $50? Would you be willing to pay $100? And the responses are analyzed by estimating the average willingness to pay and the total project value. If the average willingness to pay is $50 and the population is $200,000, then the project is estimated $10 million and it a go. If the average willingness to pay is like $10, then the project value is $2 million and it's not worth doing. So this is a very quick and easy way to do this. And the real concern here is, how do you know whether or not someone's seriously considering the question and really understands how much things are worth? So steps in contingent valuation: identify sample respondents, ask respondents their value of the good, use responses to estimate willingness to pay, and extrapolate the responses to the entire population. So the final stated preference method we're going to talk about is discrete choice modeling. If you have taken Yee's empirical I/O, you've definitely seen a little bit of this. This is essentially BLP in the framework of environmental economics. If you haven't, just think about this as we're doing a discrete choice modeling logistic regression to value, to estimate demand curve. So discrete choice modeling is a method used to estimate individual preferences by presenting choices among hypothetical alternatives. It's commonly applied in environmental economics, transportation, and public health. Respondents are asked to choose between two or more options with different levels of attributes and cost, quality, and environmental impact. So contingent valuation, I asked you how much you're willing to pay for this good. Discrete choice modeling, I'm saying here are two choices. One of them is better environment than another. Choose, and then I'm backing it out through the statistical model. So we're trying to infer the trade-off between willingness to pay. Kind of the idea of discrete choice modeling is that it's hard for people to say how much they value in dollar terms. It's really hard for someone to say, clean air is worth $500 to me. It's really easy for someone to say, yeah, here are two options. Here's what I think is better. So here's a mathematical formulation of discrete choice modeling. Discrete choice modeling, if you've ever seen logistic regression, in economics, logistic regression is a way to back out utility for the choices people make. So each respondent I is assumed to choose an alternative that maximizes the utility. The utility is from any alternative j for the respondent I. V is the deterministic component of the utility, and epsilon ij is the unobserved random component of the utility. And then the choice probability is the probability that the respondent I chooses alternative j given by probability that uij is greater than uik. One thing to note here is that we don't consider this a deterministic choice. Just because we saw someone choose something doesn't mean that they were always going to choose that. It means there was some sort of probability based on their preferences that they would choose that. So the workhorse model here is a logit. You probably have also seen a probit. In the case of multinomial logit model, it's a softmax activation function. So the probability of choosing a specific thing is the exponential of the value over the sum of the exponential of all the values. Because this thing on top is in this thing on bottom, this is always going to be less than 1, so it works with a probability. If you've ever taken a machine learning course on deep learning, this is the softmax. And this is just logistic regression. So willingness to pay is an attribute. For an attribute x, is calculated as a ratio between the attribute's coefficient and the cost coefficient. So we're going to estimate an equation for this v, and then we're going to solve for willingness to pay by using the coefficient in V related to cost, and then dividing by that the coefficient for the attribute we're looking at. So this model provides an estimate of how changes in non-market attributes affect choice probability. This allows us to back out the value from non-market goods. Like I said, it's very similar to getting a demand curve in empirical I/O. So an example of this, a study evaluates individual preferences for beach visits based on attributes like water quality, distance, and cost. So now we have water quality, we have distance, and we have cost. So importantly, this is the variable we care about. So we have other variables which are controls that we don't care about. And actually, cost is not really control. You are controlling for cost. But the reason why cost is here is not to control for it. It's because now you have a variable that directly represents money. So the ratio between this beta 1 and this beta 3 is actually going to give you a monetary value of how much you value water quality in terms of dollars, which is huge. So you traditionally, I think, are thinking about utility in terms of utils, in terms of like this theoretical ordinal construct. In this case, because we have a variable that we're modeling that represents dollars, we can say, actually, water quality is worth this many dollars to you. And then here there's also an estimation. A positive beta 1, higher water quality increases the probability of visiting a beach and increases your value of visiting a beach by some amount of dollars. And then negative beta 2 and beta 3, greater distance and cost reduces the probability of visitation. So here's a logistic regression. It's not for the same problem. This is a logistic regression performed in R. You can see that they use the general linear model package. We'll move back to this, and you do binomial logit. And then you have your variables here. You have your estimate of the parameter, your estimate of the betas. You have your standard error here. And then you have your z value, which is just your estimate divided by your standard error. Maybe you adjust for the... actually, you don't have to perform an adjustment from standard deviation to standard error because this is just the standard error. And then you have the probability value, the p-value, which is how likely the observed data is given the assumption of the true distribution. And if it's less than 0.05, you're good. If not, you're bad. And then here's some pitfalls of stated preference methods. Hypothetical bias. Response may not reflect real-world behavior since the scenarios are hypothetical. Respondents may want to intentionally overstate or understate willingness to pay. Some might be invested in the project. Also, some might just really want to represent that they love in the environment, that they really care about the environment. This is called, I think, likability bias is what comes to mind, but I don't think it's the right term. This is basically a lot of respondents will strategically overstate their value for environmental variables because they want to be liked. And then poorly designed surveys can lead to misleading results. You have to really think about how to do this and vet these questions before putting things in the wild. Initial evaluation surveys can anchor responses. You want to make sure people are putting forward the response themselves. The amount of information people have may make their answers weird. Most people are not thinking about climate change on a daily basis, so you have to make sure that they know what's going into this. And finally, the complexity might overwhelm respondents. It's really hard to think about some of these things. So thank you so much. I really enjoyed non-market valuation and cost-benefit analysis. I'll say one last thing. I encourage you to keep these slides and look through the hedonic pricing regression and the discrete choice modeling. Because if you're ever in an interview for an environmental economic consulting role or like a lot of different roles, you can say, well, I know how to do this thing, to do non-market valuation, and maybe even do it for your class project if you're interested in those kinds of rules, and be able to say to your employer, here's a time when I did that. Because that's what they really want as employers. They really want to be able to see that you've implemented these methods on some occasion. And I'll leave it there. I hope you have a great day. Thank you.